Astronomers were captivated in early July when telescopes across the world detected an unusual visitor drifting through our solar system, a celestial object that defied initial classification and sparked intense scientific curiosity. After several weeks of observation, the mysterious body was officially designated 3I/Atlas, marking it as only the third known interstellar object ever observed entering our cosmic neighborhood. Such objects are extraordinarily rare, and every new detection offers an unparalleled chance to study material originating from far beyond our sun's gravitational domain. As astronomers continue to examine its path and behavior, they quickly realized that 3I/Atlas was no ordinary comet or asteroid. Rather, it displayed a set of characteristics that raised fascinating questions about its nature, its origin, and the forces acting upon it as it journeyed through space. In late June and early July, scientists confirmed that the object was approaching its closest point to the Sun, a moment known as perihelion, when sunlight and solar radiation exert their strongest influence. As 3I/Atlas neared the Sun, telescopes detected an unexpected and dramatic brightening. The object intensified in luminosity far more rapidly than standard cometary models would predict. Even more surprising, its color profile shifted, and the comet appeared to turn a distinctly bluer shade, something that isn't typical for icy interstellar objects, which often become redder as dust particles heat up and scatter sunlight in predictable ways. These early anomalies quickly made 3I/Atlas an object of immense scientific interest, prompting experts worldwide to monitor it closely and attempt to determine the cause of its unusual behavior. Yet the visual oddities were only the beginning. A startling discovery soon followed. The object appeared to be experiencing what NASA's Jet Propulsion Laboratory describes as non-gravitational acceleration. Normally, the motion of celestial bodies is governed solely by gravitational forces, primarily the Sun's gravity when an object enters the inner solar system. However, in this case, astronomers noticed that 3I/Atlas was deviating slightly but consistently from the trajectory predicted by purely gravitational models. This raised immediate questions about what external or internal forces might be providing an additional push. NASA navigation engineer Davide Farnocchia presented a detailed technical report noting that the object's motion showed measurable acceleration unaccounted for by gravity alone. Such findings naturally triggered speculation among enthusiasts, with some drawing comparisons to past interstellar objects like Oumuamua, which also exhibited non-gravitational behavior and fueled widespread theoretical debates about potential artificial origins. On the surface, the idea of an alien spacecraft firing up its engines might sound like the plot of a science fiction novel, but researchers were quick to point out far more conventional explanations. One of the leading voices analyzing the phenomenon has been Harvard astronomer Avi Loeb, who has studied interstellar objects extensively. Loeb emphasized that the likely cause of the acceleration is simple physics. 3I/Atlas is losing mass at an accelerated rate, ejecting dust, ice, and gas as it heats up near the Sun. This process, known as outgassing, can create jets of material that push the comet in the opposite direction, effectively acting like natural rockets. The more material that is expelled, the greater the resulting acceleration. According to Loeb, the mass loss could be substantial, possibly a tenth of the comet's entire mass within a single month, a dramatic and unusually high rate of evaporation compared to typical solar system comets. Additional support for this explanation came through sophisticated observations made using the Atacama Large Millimeter/Submillimeter Array ALMA, a high-precision telescope located in northern Chile. ALMA detected a 4 arcsecond deviation in right ascension from the predicted path of 3I/Atlas, a discrepancy that is statistically significant and too large to dismiss as coincidence or measurement error. Loeb explained in an interview with NBC News that such a deviation is consistent with the evaporation of roughly 1/6 of the object's total mass, which would indeed produce enough reactive force to change its trajectory slightly. The evaporating material likely forms an expanding plume of gas and dust, pushing the object in the opposite direction, much like an engine produces thrust. Loeb even calculated that during the later part of 2025, When 3I/Atlas re-emerges from behind the Sun and becomes visible again, astronomers may be able to observe a vast cloud containing 5 billion tons or more of expelled material drifting behind it. The unusual brightening of the object may also be directly linked to this massive loss of matter. As the comet sheds its surface layers, fresh ice and volatile compounds become exposed to sunlight, triggering even more vigorous evaporation. This can cause the object to reflect more sunlight and glow more intensely. Loeb suggested that such extensive evaporation could account for the sudden increase in brightness observed earlier in the year. At the same time, however, he noted that the extreme nature of the mass loss makes 3I/Atlas unlike any other comet we typically observe passing through the solar system, adding yet another layer of mystery to its profile. Despite strong natural explanations, Loeb has also acknowledged that some features of the object remain puzzling. The blue coloration, for instance, does not align with the expected appearance of dust clouds that scatter sunlight. Normally, dust tends to redden the light, giving the comet a warmer hue. But 3I/Atlas growing visibly bluer over time seems counterintuitive if the dust cloud surrounding it is behaving in a conventional way. Loeb proposed that if the object possessed an internal heat source, perhaps even an engine, it might produce high-energy light that skews toward the blue portion of the spectrum. While he fully admitted that such a scenario is highly speculative, he noted that scientifically, it cannot be entirely ruled out unless further observations conclusively prove otherwise. In other words, while nature provides perfectly reasonable explanations, the door to a more exotic interpretation remains slightly open. Nevertheless, Loeb also provided a grounded scientific interpretation for the color shift. The blue tint could be caused by ionized carbon monoxide, a compound known to absorb and emit light in ways that can give a comet an unexpectedly cool, bluish glow. If 3I/Atlas is unusually rich in carbon monoxide, the intense solar heating around perihelion could cause the gas to ionize and alter the object's visual spectrum in a way that mimics artificial illumination. Until more data is collected when the object becomes visible again, both possibilities, natural and speculative, remain topics of ongoing study. Importantly, Loeb and other astronomers emphasized that the non-gravitational push acting on the object will not be strong enough to send it significantly closer to any major planets or dramatically alter its long-term journey out of the solar system. The acceleration is measurable, but still quite small compared to the massive gravitational forces at play. Still, understanding these subtle forces is crucial for accurately predicting the object's path and for refining models of how interstellar bodies react when they are exposed to the intense environment surrounding a new star. Of course, following the object and gathering data has been complicated by real-world challenges. Loeb revealed that the ongoing government shutdown in the United States has disrupted scientific communication and access to certain NASA resources. He noted that he had reached out to interim NASA Administrator Sean Duffy to request access to observational data from the Mars Reconnaissance Orbiter, which may have captured imagery of 3I/Atlas as it passed near Mars the previous month. However, due to agency disruptions, he had not received a response. Loeb expressed frustration that withholding or delaying vital scientific data could hinder the global astronomy community's ability to plan future observations. With interstellar objects being so rare, any missed opportunity to collect high-quality measurements represents a lost chance to deepen our understanding of the broader galaxy and the material traveling within it. Despite the challenges, astronomers remain eager to continue studying 3I/Atlas once it comes back into view later in 2025. Its highly unusual characteristics, from its dramatic mass loss to its unexpected coloration and non-gravitational motion, make it one of the most intriguing interstellar visitors ever recorded. Many hope that renewed observations will provide clarity, revealing whether its behavior is simply the result of extreme natural processes acting on a highly volatile object from another star system, or whether 3I/Atlas will join the growing list of cosmic anomalies that challenge conventional scientific expectations. Regardless of the final explanation, the object serves as a valuable reminder of how much we have yet to learn about the wider universe and the countless bodies drifting through interstellar space on journeys spanning millions or even billions of years.